Hey everyone, welcome back to another video. In today's video, we are going to be talking about a special right triangle known as the 45-45-90 degree triangle. Let's go ahead and let's get started. So most of the times when you're working with right triangles, we're usually working to find the missing side, and a lot of times we use the Pythagorean theorem. The nice thing about special triangles is that you don't necessarily need to use the Pythagorean theorem. Sometimes it can take some time, and there's actually shortcuts that we can take with certain triangles that require us to know less information than we would for a Pythagorean theorem problem, and we get the answer significantly faster. Okay, so for Pythagorean theorem, if I want to use that, I need to know at least two side lengths in order to be able to solve it, and I plug them into the formula a squared plus b squared equals c squared. Here, however, I can use the 45-45-90 degree triangle theorem to help me solve this question. With just knowing one side, I can find the other two remaining sides, and I can do it much faster. The key is being able to spot when you're working with the 45-45-90 degree triangle. So really, the key things about these types of triangles is that your two legs, the two shorter sides of the triangles, these are going to be the exact same length. So let's say one of them was length S, which is just a random length. The other leg would also be S. The hypotenuse, the longest side of triangles like this, in order to find that, we simply just take S and we multiply by the square root of 2. And this is the formula that I would use in order to solve for any missing sides, or really the other side that's identical. And all I need to know is what one side is. If they tell me that what the hypotenuse is, I divide by the square root of 2 and I know the two missing sides. If they give me one of the legs, I know that the other leg is going to be exactly the same, and that the hypotenuse is simply that same number multiplied by the square root of 2. So let's take this triangle here, for example. Let's pretend it's a 45-45-90, even though the side lengths, I know the legs don't look like they're the same, but we'll pretend they are. If I was told that this had a length of 4, then I know that the other leg to this triangle would also be 4, and that the hypotenuse would be 4 times the square root of 2. And I have solved for all the sides of this triangle. Then that's the nice thing about this 45-45-90 degree triangle theorem, is that by just knowing what one side of this triangle is, I'm able to solve for the rest. So let's say they give me the hypotenuse here, which is 12. Okay, I could use this to help me. I can spot right away that this is a 45-45-90 degree triangle theorem, or triangle, because I see the two 45 degree angles. So I'm going to do 12 divided by the square root of 2. Okay, which this is an improper fraction because it has a radical on the bottom. So the way we fix that is we multiply by that radical in the form of 1. And then this turns into 12 square root 2 over the number 2, which is just 6 square root 2. Okay, so now I know that these two legs are 6 square root 2. And that's how we use the 45-45-90 degree right triangle theorem. So hopefully now you feel like you can solve for missing sides of a triangle by using the 45-45-90 degree triangle theorem. Again, this method is much faster than using the Pythagorean theorem. The only key is it only works with triangles that have two 45 degree angles and one 90 degree angle. So right triangles with two 45 degree angles, pretty much. Other than that, there's one more special triangle that we're going to talk about, which is a 30-60-90. Check out that video after this one once you've understood the math. But as always, just want to thank you for watching, and I'll see you guys next time.